Good morning, Muhammad Saeed with you, physics teacher. Today we are going to talk about Newton's first, second, and third law. First, standard speech, Newton's law. First, second, and third law. Now we are going to compare between Newton's first law and Newton's second law. Newton first law and Newton second law. And what is the difference between them? Okay, Newton's first law answers the question that says what happens if there is no force acts upon an object. As we imagine that, we ask Newton, what happens if there is no force acts upon an object? Okay, Newton answered this question in Newton's first law. But the Newton's second law answers the question that says, what happens if a force acts upon an object? Again, Newton's first law answers the question that what happens if there is no force acts upon an object? What will happen? Okay, Newton's first law answers this question. While Newton's second law answers the question that says, what happens if a force acts upon an object? Newton's second law answers this question. Okay, Newton's first law says that if there is no force acts upon an object, what will happen? Newton's first law says that the static object keeps its state of rest and the moving object keeps its state of motion with uniform speed and in the same direction. Okay. Again, Newton's first law says that the static object, keeps its state of rest, okay? And the moving object with uniform speed keeps its state of motion with uniform speed and in the same direction unless it is acted by an external force or external influence called force. Okay, in this law, Newton says that if there is no force acts upon an object, the object state doesn't change. What's meant by object state? Newton says that if there is an object that is at rest and no force acts upon this object, so it keeps its state, it remains at rest. Okay? And the moving object with uniform speed, for example, moving car that moves with uniform speed, it moves with uniform speed because the resultant force that acts upon it equals 0. Okay, if I ask you a question, why we keep pushing the benzene pedal or the accelerator of the car, although its speed doesn't increase, we keep pushing the accelerator of the car, although its speed doesn't change or doesn't increase. Okay, Newton said that if the object state doesn't change, this means that there is no force acts upon this object according to Newton's first law, which means that the car speed doesn't change because the car pushing force or the engine pushing force forward equals another force called friction force, the resistance and friction force. In this case, the force, car pushing force, equals friction force. So summation F equals what? If the car pushing force minus friction force equals 0. So we can represent Newton's first law as summation F, the resultant force equals 0, which means that if there is an object, if we have an object and this object doesn't affected by an external influence called force, it keeps its state of rest if it was at rest, or it keeps a state of motion with uniform velocity in the same direction. In this case, in the first case, the POC, for example, POC in this case doesn't change because there is no force acting upon it. But in this case, the car doesn't change, the car speed doesn't change because the resultant force equals zero, although there are forces as summation or some forces that act upon it, but they cancel each other because they act in opposite direction. They are equal in magnitude and act in opposite direction of each other. So the resultant force in this case equals zero. So again, Newton's first law, the static object keeps a state, such as the POC, it keeps a state of rest because there is no force acting upon it. You can say that there is a force acting upon the POC, so there is a force that acts upon this POC, which is called gravitational force or weight. Newton said that because the POC doesn't move under this force, so there is another force that acts upon this POC in the opposite direction called of reaction. The force of reaction, called force of reaction. Okay? So again, we have a POC placed on a table. So there is a force acting downward, which is called gravitational force or weight. It's weight, but it doesn't move. So there must be another force that acts upward, which is called force of reaction. So that the POC doesn't change because the summation of forces equals zero. The resultant force equals zero. Okay? So this is the mathematical formula of Newton's first law. Summation F equals zero. Again, the static object keeps its state of rest, and the moving object keeps its state of motion with uniform speed in the same direction unless it is acted upon it by an external influence called force. Okay, this is Newton's first law. Okay, Newton's second law answers the question, what happens if there is a force acting upon an object? What will happen? Newton said that if a force acts upon an object, the object state should change. If we have an object and there is a force acting upon this object, the object state should change. If a force acts upon an object, the object state should change. What's mean by state? State means acceleration, which means the object should acquire an acceleration. An acceleration means two things: speed, or its velocity should change. Speed, I mean by the word speed, its magnitude, or direction. Again, if a force acts upon an object, Newton said that the object state should change. The state means acceleration. The object should acquire an acceleration, which means the speed of the object or its direction, one of them must change, or both of them. If a force acts upon an object, the object should acquire an acceleration, which means its speed or its direction should. Newton's second law, the formula of Newton's second law, there are two definitions for Newton's second law. If the resultant force that acts upon an object, the first formula, if the resultant force that acts upon an object, the object acquires an acceleration. The object acquires an acceleration that is directly proportional to the acting force and inversely proportional to the mass of the object. Okay, so we can say that when a force acts upon an object, the object should acquire an acceleration. This is the mathematical formula of Newton's second law. When a force acts upon an object, the object should acquire an acceleration. And this acceleration is directly in proportion to the force at constant mass, which means by increasing the force, the acceleration, the change of the object's speed or direction increases. And it is inversely proportional to the mass of the object, which means that if we have two objects, the first object 1 kilogram, for example, and the other object 10 kilograms, for example. Okay, the same force acts upon them. So the first object acquires an acceleration while the other object acquires acceleration less than the first acceleration, because by increasing the mass of the object, the acceleration acquired by this object decreases, which means that the acceleration is inversely proportional to the mass of the object. Okay, this is the first formula of Newton's second law. Okay, what is the measuring unit of force? Measuring unit of force is Newton. Okay, so we can say that the force is measured by unit called Newton and the mass kilogram, acceleration meter per second square. So we can say that the force that acts upon this object equals 500 Newton or 500 kilogram meter per second. So we can say that Newton is equivalent to kilogram meter per second square. Okay, another formula for Newton's second law. Newton's second law. A force equals delta P, which is the momentum of the object over delta T. So we can define Newton's second law from this relation. The resultant force that acts upon an object, the resultant force, that acts upon an object is directly proportional to the time rate of the change. We must say change. This triangle means change, which means that the momentum should change. The time rate of the change in its momentum. Okay, F equals delta V over delta T. Momentum equals what? Momentum, we have learned before that momentum equals M delta V over delta T. Mass times velocity. And delta V over delta T equals what? MA. So we can say that Newton's first second law equals mf delta V over delta T, or equals m times acceleration. This is another formula, another form of Newton's second law. Okay, thank you.